We're wearing today, so we're going to be a little bit more boring today. I even have boring shoes today.
Today we're talking about 1.7 summary statistics for a quantitative variable. We're going to calculate measures of center and position for quantitative data. We're going to calculate measures of variability for quantitative.
We're going to scare them. They couldn't make it through that video.
Right. Okay.
We're really here today. Don't stop
the video. All right. So we are going to talk about a lot of stuff today. This one is a little more content heavy. I might talk a little bit fast, so at some points if you need to stop, pause the video, read what's going on the screen, please do that. But we're going to kind of truck through this, okay?
Let's do it.
So the first thing I want to talk about are measures of central tendency, which are means and medians. And we've already discussed means and medians. You've been talking about it for years. But
make it hard.
Right. But say it again, Mr. Bobby.
What's up with that like blue box there? I don't get it. Why is it got a hat?
Okay, so what he's talking about here is the formula for mean that we use in statistics, and because things are never as easy as we want them to be, we know how to find mean. We add up all the numbers, we divide by how many numbers we added up, right? That's what this formula tells you, okay? So looking at the formula, I'll kind of walk you through it. This is called X bar. X bar represents sample mean, okay?
And we still compute it the way we're used to, but in statistics, that's when we gather what we can pull from some bigger population. We don't know for everybody, so that's kind of where we hedge our bets. I mean, we've been hedging our bets all along.
Right. So then the formula says 1 over n, and then this weird thing, and then tiny number below, tiny number above, or letter above, and then an x sub I. So let's start with this.
That's a Greek letter, and if you're going to go to college and join a fraternity or sorority, you should probably start learning your Greek letters now. That's the Greek letter sigma, which used to be like Greek for S, and S stands for sum. So like if C is for cookie, S is for sum, S-U-M, not S-O-M-E. So we're going to add up all the numbers.
Yeah.
Or sum them, S-U-M them. And then that's what that means. That sigma means add up all of the X's, and X's are all the numbers we gather.
And in this formula, there are n numbers, right? So you would add the first number all the way to the nth, or the last number. And then you would 1 over n, that's the same thing as dividing by n, okay?
Well, dividing by 1/10 is the same as dividing by 10. Like, and if you didn't really ever understand fractions, just believe us on that one. Yeah. But it is the same.
Now, I say all of that to tell you, just find mean the way you always find mean. I just don't want you to see this formula and be like, what? Do I do something different? No, you don't do anything different. Just keep finding it the way you find it.
Okay, roll on. Let's talk about median.
Okay. I'm not going to wax philosophical about this. The median is when you take the numbers and you put them all in order, and then you find the middle one. And if there is no middle one, you find the average of the two middle ones. Yeah? And then last thing, if you change units of measurement, that's going to affect your calculated statistics. So if all of your measurements are in inches, and then you convert them all to feet, that means your statistics are going to change with the conversion, which is not shocking, right?
And we're going to kind of see that in one of the examples you have here in a second.
So let's look at this bad guy. So it says today, Arkansas's incarceration rates stand out internationally. Now, I want you to understand that all the data we look at is from the last census. The last census was 2010 because the 2020 has not come out yet, okay? So look at the data. You might pause here to kind of visually understand what's happening. We are comparing Arkansas incarceration rates to the NATO founding countries, okay? And what do you see, Mr. Bobby?
I see an orange bar that is longer than every other bar for Arkansas. And Arkansas and the United States are so big they can't even be contained in the box.
Okay. So, you know, arguably, this is actually bad statistics. Why would I say this was bad statistics?
Well, you're trying to like be dramatic here by putting the box there, and by having those go past the box, like I said, you're really trying to make me invoke an emotion. And that's not what we really want as a statistician. Now, granted, that happens emotionally, it happens on Facebook and whatever, but there's
Keep
no
your emotions on social media. So, yeah, like that box should not have ended before the last bar ended. And really, that bar shouldn't be orange. Well, let's not like, it's obvious that there's something going on here. And during this lesson, I'm going to try really hard not to, make a judgment about any of the things that we show you. Okay.
The lesson will be it can be perhaps a little upsetting, and that's not our intent. We don't try to separate the context from the statistics, because it's very important. It's important mathematically, statistically, but it's also important socially. But we're not going to deal with the social issues.
I want you to understand that as a statistician, you aren't trying to push your opinion into the data, which is what happens a lot, is people push their opinion into the data. Really, you just lay out the facts, and the consumer should be able to understand what you're saying. But anyways, okay, so we got two types of measures of central tendency, mean and median. So we're going to look at countries only. We're going to leave Arkansas out because it's not a country. We're going to compare what Mr. Bobby says, apples to apples here, and leave the orange out. How did you notice the color match?
And this is what you're saying about the units need to align. We can only really compare countries.
Yes. Yeah. So if I want to find the mean, I add up all of these incarcerations per 100,000 people. And then I should really right here have put 143.1 per 100,000 people. Okay. And then if I want to find median, then I take all my numbers and I put them in order. Now you can see I underline the first half and I underline the second half, and there is no middle number. So then I take the two middle numbers, I add them together, divide by 2, and that's going to give me a median of 99 people. So, Mr. Bobby, which one do you think represents the data?
See, I got a real problem with this, because if I look at these numbers, 143.1 and 99, they first of all, they vary by like 44, which is not cool. They're kind of far apart. But if I look at 143, but then I go back and actually look at the actual numbers, 143.1 is bigger than every other country except the United States. Okay. And that doesn't feel right to me when I'm talking about trying to find an average or find the middle. It just seems too high. And then when I look at the median, 199 is kind of like between France and Italy, so I'm kind of feeling a little more balanced there. Okay, so I'm liking the median a little bit better from this example.
I'm definitely liking the median better as well. So what we have are statistical measures that are considered resistant to extreme values, and statistical measures that are considered non-resistant to extreme values. And that's what you just saw in the previous graph was, United States was so much larger that it really pulled the mean towards it. So think about like if you are at a party, you and like your 20 best friends are at a party, and all of you are about 17 years old. Like most of you are 17, some are 16, some are 18, but most of you are 17. And so like if I took the mean of you, the mean would be like 17. And if I took the median of you, listed you all in order, it would be 17 as well. Then like you have the raddest grandma ever, and she wants to party. And so she's like 80. And so 80-year-old grandma comes to party with you, and you take the average, now the mean of your party, and the 80's really going to pull the average up. Let's say it pulls it up to 26 years old. Well, there are no 26-year-olds there. 26 doesn't really represent anybody at the party. You got grandma and you got y'all.
So which of those three graphs then would be grandma at the party?
Right. So
we would skew the data to the mean to the right. So she would pull, and that would have, the tail would be on the right side.
That's right. And the median really would be unchanged. It could potentially shift one number. And, you might go from like 17 to 17 because you'd have a bunch of 17s listed out. So it could change it if there were other numbers, but it's really not going to change it much.
No.
We consider the median to be resistant to those extreme values, and we consider the mean to be non-resistant to those extreme values. Your grandma doesn't come party with you? Is that what you're saying?
Go on, because before too much longer, you and I are going to be grandma and grandpa.
That's true. But I'm not coming to party with any of y'all.
No.
So one more thing here is if your mean, median, and your mode are all the same, then that would be a symmetric graph. Or if they're approximately the same.
Close together.
Right. So like if you had that party and somebody's 20-year-old brother came in, he probably isn't going to change it very much. You're still going to be pretty much symmetric when you graph it. Okay, so let's look at this histogram. It says the histogram shows the distribution of the percents of women aged 15 and over who have never married in each of the 50 states and in DC. When describing the distribution, which measure of center would you use?
Well, since we got that group over here, or that little cluster, or maybe an outlier, at 40 or 50 to 52, that's going to pull the data. And now if I think about a shape of this, it would be something like that. Not the best bell curve I've ever, or graph I've ever drawn, but it's skewed to the right. So I wouldn't want to use mean for this set of data.
In this case, this would be grandma, right? That would be grandma?
Yeah, I guess now it is, because you're talking.
Okay. I think you get the point here. So moving on. Okay, let's do this one. You've got comparative dot plots here, and each dot represents a sample of a PVC pipe and its length. The centers are about 600 millimeters, and we've got two suppliers, supplier A and supplier B. So we want to notice here that the supplier A's dots are all kind of squished together, and supplier B's dots are really spread out. So A is what's called less variable, or has less variability, because there's less variation in the information. B has a larger variation in the lengths. If I'm trying to pick a supplier to buy from, do I want them to be consistently all about the same length? Or do I want them to be a little less consistent with their lengths?
And that may, if you're a plumber, you may want the consistency so that you're not trying to put something together and you run short. Okay. You want the equipment to be what it is. But when you're doing that with your hands, that's great. And it helps me describe it, but like mathematically or statistically, I need more than this.
Okay, good. Because I've got more than this. All right, so let's be a little more concrete here. We talked about the range, which we could actually see that big change in range, or we had a little range and then we had a big range. But really we want to talk about how much do the data points vary from the average? How much do the data points vary from the average, or vary from the mean, I should say? And we call that number, this new average we're going to create, the standard deviation. What is the deviation? What is the change from the mean when we start looking at the data points? And we've got another complicated formula here. We're going to call the sample standard deviation S sub x. And it looks like we're going to take each data, subtract the mean, square them up, add them up, divide by n minus 1, and take the square root.
And if you didn't get all of that, that's okay, because you're not going to have to compute this by hand.
Yeah.
But you need to understand that we're talking about variability and how spread it is. And when I think about this, see the word deviation and I think of deviant. When I think of deviant, I think of somebody who's a little bit off from normal and how far they are away from being normal. So we're looking at a data point and saying how far is kind of a general measure of how far the average point is away from the mean.
Yeah.
They're not all going to be the same, okay?
Okay, so we're going to talk about standard deviation, but I need to lead you up to some information. So if we think about how are people of color potentially overrepresented in prisons and jails, we might be presented with this graph. So what we have here is the Arkansas incarceration rates by race or ethnicity in 2010. And this is the number of people incarcerated per 100,000 people in the ethnic groups. And we look at this graph and we say, wow, there's a lot more African American people than any other type of ethnic background. But why should we question this graph? Like, we want to talk all the time about being a good consumer of information and not being tricked by things that are true but maybe aren't representative. So what do you think, Mr. Bobby? What's wrong here?
Well, what I don't understand about this graph, or what I don't know about this graph, is I don't know the racial breakdown of Arkansas. And possibly not every race or ethnicity is represented here. So there's a couple questions that I have about this just at a quick glance.
Right. So what I might ask myself is like, well, are there twice as many Black people living in Arkansas as Hispanic people? Or are there, 4 times or 5 times as many Black people as white people and living in Arkansas? Because if there are, then this is a good representation of the population and I'm fine with it. But if they're not, then maybe there's a further conversation there. Okay, so I present you with a different graph. So on the left side of this graph, these dots with these percentages represent the population of the state. So 75% of Arkansas is white, and 15% is Black, and 6% is Latino, and 1% is Native American. And on the right side, these blocks are the percentage in prisons and jails in Arkansas, okay? So 50% of the prison population in Arkansas is white, and 42% of the prison population in Arkansas is Black, 7% Latino, and 1% Native American. Does that make sense, Mr. Bobby?
Yeah, now I like this graph a little better because I have some comparison between the two and some frame of reference, and I can tell if I do the math that you haven't addressed every ethnicity. So I can attend to the questions I had earlier.
Okay, so we're a little more thorough now, which should, and then we should maybe begin to raise a brow, because as we start doing our comparison of statistics, we see a change. And anytime we see a change or something different when we start doing comparative statistics, that should raise an eyebrow. Okay, so here's what I grabbed. I grabbed the African American percent of state and prison population in former Confederate states. So you've got Alabama, Arizona, Arkansas, and up. And then the first line of values is the state population of African American peoples. And the second line of information is the prison population, the percent of prison population.
And this is still based on the 2010 census, right?
Yes, we don't have any new census information.
20th census, because it's still being in the process.
Yeah. Yeah. Okay, so what might we want to know? Well, I like to just lay it out. So I threw it on a dot plot. So we're kind of looking at the dot plot. And we're going to talk about a lot of things here about this data. But if I want to talk about how much do the states vary? Like, how much do the Confederate states vary with each other in terms of their state population of African American people and prison population of African American people? What's one value I could use?
Well, you could use the range. I could see it seems to be that the range is higher for the prison population than it is for the entire state population.
So we have a range of about 34% within the states And then we have a range of about 60% within the prisons. Now, I still feel like I could do better talking about the variability of the data here. So what's another way I can talk about the variability of the data in this case, or in any case? I can switch to the standard deviation. So at this point, I want to look at how does the data compare to the mean? How does the data compare to the mean? And we're going to start with the state populations.
And just so you don't get lost in the statistics here, we're going to compare the population of African Americans in the state to the population of the prison population of African Americans. So that's what we're going to compare. And we can
and there's
see
a big lead up here, because that's actually, that comparison actually isn't going to happen until the next video. So
that's where we're ultimately going. So
yeah. Okay, so our mean here in the Confederate States is about 20.7. So about 20.7% of the population in the former Confederate States of America is about 20.7% African American. I feel like I just repeated myself, but I think you get the point there. Okay, so here's what we do. Here's how standard deviation is found. And remember, we're not going to ask you to find this by hand, but it's important for you to see this at least one time, okay? So remember, standard deviation is the average distance from the mean to the data points, okay? So if the mean is 20.7, then the distance from 26 to 20.7 would be about 6. The distance from 30 to 20.7 would be about 10. And then I could continue to do this.
the problem with it, though, is Alabama is 6 above, and for example, Arkansas is about 6 below. So when she's talking about distance, she's not worried of necessarily thinking about numerical values, but I do, because I'm kind of a more literal. So does that above and below matter? And how do we deal with that?
Right. So it does matter. So the formula itself, the one that's going to determine our standard deviation, tells us to find that average, to find that distance by subtracting. So if I subtract my value minus my mean, which is what it tells me to do here in the formula, then I get 5.3, 9.3, and I did 20.7 because I was too lazy to type 714. And then right here, I started getting 5.7, or negative 5.7, negative 4.7. So remember what I'm trying to do here. I'm trying to find the average distance. So what would happen now, Mr. Bobby, is if I added up all of these distances to find the average.
So I have some positive and some negative, and they're going to like eat each other up, and they're not all going to be the same. So one, and how we do it in statistics, there's a couple ways we could get rid of the sign, and the one obvious one would have been to do absolute value, but that's not what the ones the statisticians did. They took the square root. They took the square root of the squared number. When you square a number, any number, it becomes positive. If you take the square root of a square,
right. So then the next thing we're going to do then is square them. And remember, we're squaring them to get rid of that negative issue. We're undoing the negative issue by squaring all the numbers. Now, looking back at my formula, once I've squared the numbers, then I would sum them up and divide by n minus 1 in this case. And the n minus 1, there's a reason behind it, but we're not going to talk about it. So when I add them all up, I add up all these squared numbers and divide by n minus 1, I get 113.758. That number actually has a name, and it is called the variance, okay? Then the last thing I do, see this huge square root over the formula here, is I take the square root and I get the standard deviation, which in this case is about 10.666 or 10.7. So what does 10.7 mean? How do I interpret that? So the percent of African American population of these states typically varies by about 10.666% from the mean of 20.714% African American population. Okay, so what it's saying, and when I ask you to interpret this, you're going to need to talk about what is the standard deviation, what is the mean and what is the relationship between those two numbers.
And the bigger that number is, the more spread out the data is. The smaller that standard deviation, the more clustered or closer to the mean they are. And that's the meaning behind it, but we'll talk more about that later too.
So pause and recap. If we want to find standard deviation, we find the mean, we calculate the deviation by subtracting, then we square those deviations, then we add all those numbers up, divide by n-1, take the square root, and that returns us to our original units. Okay?
I have to do it with my hand.
Yeah. So sidetracking for just a minute, let's make sure we understand standard deviation. A list has 10 numbers. Each number is either a 1, a 2, or a 3. The average of those 10 numbers is 2, but the standard deviation is 0. What is the list of numbers?
Okay, so I know that I've got 1s and 2s and 3s, but the standard deviation 0 tells me there's no change in the numbers, so they got to all be 2s.
Why do they have to be 2s? Why can't they be 1s?
Because I know the average or the mean is 2. So if I add all those numbers up and divided by, I guess there was 10, I add them all by 20 and divide by 10 and get 2. But that's how I can get the mean. Now, granted, I could have traded a couple of those 2s for a 1 and a 3, but the moment I have something other than 2, my standard deviation starts to grow.
Right.
So since the standard deviation is 0 in this situation, there's no deviance from the mean. All of the numbers are exactly mean. This almost never, ever happens.
Right. Okay, so let's look at these lists, A through E. These are different lists. Each of these lists have a standard deviation of either a 1 or approximately a 1, a 2, or a 10. So if I look at this, and remember, we're thinking distance from the mean. Maybe you should pause the video at this point and just make a guess at what you think the answer is. So we're going to let you pause, and then we're going to move forward. So 49, 51, 49, 51, 49, 51. What are you noticing, Mr. Bobby?
Well, one of them's below and one of them's above 50, and it keeps alternating from above and below 50. So every one of them is one space away from the mean of 50. So I'd say the standard deviation is 1.
Right. So 1 above, 1 below, 1 above, 1 below. So on and so forth means that each of those numbers deviates 1. So 48, 52, 48, 52, 48, 52, 48, 52.
Right, but this time 2.
Right. Deviating 2 from the mean. Now, guys, this rarely happens. You don't have this like obvious deviation like this. So let's make it a little more difficult. 48, 51, 49, 52, 47, 52. So if we start looking at the deviations from the mean of 50, this is 2, this is 1, this is 1, this is 2, this is 3, this is 2, this is 4, so on and so forth. What do you think, Mr. Bobby? 1, 2, or 10?
Well, they are all 1, so I'm guessing it's about 2.
Yeah.
They're a little bit farther away than 1, so that's got to be about 2.
Okay. The next row are deviations from the mean would be 4, 1, 4, 1, 1, 3, 0, 0, 1, 1. What do you think?
You got some 4s and 1s. I'm a little torn between it's maybe 2, but a couple 50s in there that throw me off.
It is actually 2, but it is like 1.8 or something like that. It rounds.
So that one is a little harder, but that's okay.
Yeah. And then 60, 36, 31, 50, 48. Looking at our deviations, we have like 10, 14,
17, and so on. So you got bigger numbers, and of the 3 choices you gave me, I'm thinking now we're up to about 10.
Yeah.
Because we got bigger deviations.
Right. So there is a way that you can grab a quick standard deviation. There's a couple of ways. I thought I would take a minute here to show you, you can see how many tabs I have open here. I just lost it. There we go. So take just a minute here to look at, I'm going to copy this list of numbers, and I'm going to run over to this website called stafflet.com, and I'm talking about one categorical variable, one quantitative variable and a single list of numbers. Okay, and I'm not even going to give it a name.
On the website, I'm sure Ms. Young will have this online for you.
Yes, yeah, you will definitely be heading to this website. So I'm just going to throw the data in. I'm not even going to give anything a name. And then I'm just going to begin the analysis. It's going to give me a dot plot. But below that, it's going to give me a summary statistics. And which one do you think I want to look for if I'm looking for standard deviation?
I would probably say SD because
probably, yeah, SD. And our standard deviation in that case is 9.809. So yeah, our answer of 10 made us correct.
And if you noticed real quick, it gave you the mean. It also gave you the min, max, Q1, Q2, and median. You might recognize some of them. We'll talk about that a little bit later too. But
yes. Okay, so here we are again, back to our data set. Here are our dot plots. Let's make some sense here. Here's our state information. Here's our prison.
A little while ago when we did. Now she's just going to do the second set for the prison population. That she could have used Staplet or done it by hand. I don't know how she got it. I'm assuming she used technology.
I 100% use technology, yeah. So we have numbers now that we can begin to compare. We've got a state mean of 20.7 and a prison mean of 45.8. And in the deviation, standard deviation, we have 10.6 in the state and 15.8 in the prison. So look at the data. Why is the prison standard deviation larger than the state standard deviation? What do you think, Mr. Robbie?
Well, you got that 1 point way out to the left in New Mexico, which I didn't know was a Confederate state. That kind of surprised me, but that's kind of cool. I learned something else new today. But that point there at 6 is kind of causing the standard deviation to be large as well.
Right. See this large range? These larger ranges will have larger standard deviations, and these smaller ranges will have smaller standard deviations because the data is closer together. Okay. So what's creating a prison range that's so much larger than the state range? What do you think?
Well, partly it's that
yeah. Look at New Mexico. New Mexico was 2 and only jumps to 6. Whereas when you're looking at all the other states, they have a much larger jump in percent population. New Mexico doesn't really change very much though. And so it's keeping that range and that standard deviation larger. So if you're like me, at this point, you're like, why? Well, you're like, first, I think that's an outlier.
Right.
I wonder if I can prove it's an outlier. And then the second thing you should be thinking is like, why? Why is it an outlier? Why is New Mexico so much different than all the other states? So you're about to see my daughter walk by.
And if you were thinking that, you might be a statistician.
Yes. So, whoa, where did my video go?
I don't know.
There it is. Wow, okay, just kidding. We're gonna do something first and then we're gonna watch the video. I forgot what order I taught was teaching in. So, if you're questioning whether it's an outlier, you should be. And so you're gonna go to, how do I know if something is an outlier? And if we're talking about standard deviation, the general rule of thumb is if the value is more than 2 standard deviations above or below the mean, then it is an outlier. We can officially call it an outlier. So let's go back to our graph and our data. Our prison mean was 45. We suspected that this 6% was an outlier. So we're gonna ask ourselves, is it 2 standard deviations below? So our standard deviation for prison was almost 16. So if we're at 45 and we drop 15-ish, that takes us to 30. And if we drop 15-ish, that takes us to 15. And is 6 less than 15?
Yes, it is.
It absolutely is. And so we can officially say that 6% is less than 2 standard deviations below the mean.
And different books and different subjects might define outliers slightly differently, but this is our standard deviation or our definition of outlier for this course and for
yeah. So here we go. I asked a friend of mine, I said, why, once I determined it was an outlier, I sent him a text and I was like, why is New Mexico an outlier when comparing blah, 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 blah. And he was like, good question. And he sent me the longest text message back ever. He's a brilliant guy. And I was like, and then I'm not a history teacher, so I didn't want to explain that to you. So I asked him if he would make you a short video explaining why New Mexico might be an outlier in our data. And he came up with this beautiful explanation. So
I think there could be a few explanations for this. First, New Mexico's allegiance to the Confederacy was complicated. In 1860, New Mexico was a territory, not a state. Therefore, when the war broke out, there was no federally recognized state legislature to declare one way or the other. Yes, many in southern New Mexico supported the Confederacy, and Texas did lay claim to the southern half of the territory, including Arizona. However, a rival pro-union government made a simultaneous claim to the region. And then, by 1862, Union forces out of California and Colorado defeated Texan forces in what would become known as the New Mexican Campaign. In the end, the Confederacy controlled New Mexico about as much as my dog controls my refrigerator. 2, New Mexico saw massive demographic changes in the 20th century. While it's impossible to know for sure what New Mexico's Hispanic population was in 1860, what we do know for sure is that it was nowhere near as large as it is today. According to the 2010 census, Hispanics make up half the state. That number is probably much larger by now. This could affect minority prison populations in all sorts of complicated ways. 3, and most important, the implementation of Jim Crow, or maybe lack of. While New Mexico certainly had Jim Crow-style legislation, it was never state mandated like it was in other Confederate states. Communities and school districts were allowed to choose for themselves whether or not to implement Jim Crow. As a result, many didn't. There's a real possibility that there's a stronger relationship between modern prison populations and Jim Crow than there is between modern prison populations and Confederate states. It's just that most Confederate states implemented statewide mandatory Jim Crow regulations.
So how about that? Maybe we should have been looking at a different set of data, but this is the one I wanted to look at. All right, so I thought that was very well done. I hope you learned a little something from it.
I know I did.
All right, so we just figured out that we have an outlier, Mr. Bobby.
Mm-hmm.
And so we just did mean and standard deviation for a data set that has an outlier.
And you just said earlier on that outliers mess up the mean.
Right. So that tells me that I have to start all over again. I can't use mean and standard deviation. I now need to use medians. So when we start breaking down statistics using medians, we need some different information. We need to take the data and split it into quarters, which we call quartiles. So we want to know what's happening in the first 25%, the second 25%, the third 25%, and the fourth 25%.
And hopefully this feels a little familiar to you.
Yes, yes. So the first quartile, which we call Q1, is the median of the first half of the data. And the third quartile is called Q3, which is the median of the second half of the data. Then in place of standard deviation, we have what's called interquartile range, which is when we subtract Q3 minus Q1. And that tells us where the middle 50% of the data is falling. So what's happening now is I'm just basically ignoring like New Mexico in this case. I'm saying, you know what, let's ignore New Mexico. There's something weird there. And let's only focus on this middle. That also allows me to ignore any states that have really high, right? So we're only focusing on like the average of the average, which is so weird.
Well, it's more typical. The middle 50% right. Tends to be more typical data.
Yes, yes. Okay, let's go back to our data. And what we're going to do now is we're going to look at the state data and we're going to put it in order. And then we're going to determine the smallest and the largest. So the minimum is 2, the maximum is 37. Then we're going to find the median. So we're going to look at first half of the data, second half of the data. If it's an even data set, then we have to add the two middle numbers, divide by 2. So the median of this data set is 20.5%. Then we take the middle number for the first half of the data, which we're going to call Q1, and the middle number for the second half of the data, which we're going to call Q3. And then from here, we're going to find the interquartile range, which we'll call IQR in this class. The IQR is found by just subtracting Q3 minus Q1, which is 30 minus 15 in this case. And so our typical or middle 50%, middle half of the percentages of the African American populations in the States varies by about 15%, which is pretty small actually when you think about it.
And when she said it divides our data into quarters, when we technically 15 can't be in both quarters at the same time, so it's actually 25% or less of the data is below 15. 25% of the data and less is between 15 and 19. So technically, that's just kind of a little.
Yes. Okay, so let's do the same thing for the prison now. These 5 numbers that I found, the minimum, the maximum, Q1, the median, and Q3, these 5 numbers are referred to as the 5-number summary, okay? So as we begin organizing our data, meaning we put it in order, we find the first half of the data, the second half of the data, and so on and so forth, then in my mind, I work from left to right. So the first number I will put is the minimum. The next number I put is Q1. Then I'll put the median, which is the average of 46 and 48, or halfway between 46 and 48, which is, I'm saying 48, I'm meaning 50. Halfway between 46 and 50, which is 48. Then I will give Q3, which is the middle of that second half of the data, and then finally the maximum. That's called the 5-number summary for your medians, okay? And then we find IQR, which you can't see because it's behind this black box being annoying. And so to find IQR, I just subtract Q3 minus Q1, so 57 minus 41, which is 16%.
So let's think about New Mexico now with is it still an outlier?
So we're gonna circle back to determining if something is an outlier and then based on medians in the next video, so that this one doesn't go on and on and on. Yeah, that's okay. All right, so one more thing we need to talk about, we actually already talked about it, is the pth percentile, which is interpreted as the value that has p% of the data less than or equal to it, okay? So one more quick thing before we end this video so we can start again. Let's say you're trying to make lemonade out of your lemons, which is what I try to do my whole life. The graph to the left gives you the percent of juice lost after squeezing the lemon per second. So the first thing it asks us to do is determine interquartile range based on an ogive. But I did it based on data. So what do you think, Mr. Bobby?
Well, you have the interquartile range is between 25% and 75%. So I need to find those percentages along the vertical.
Yep. So we need the middle 50%, remember? So we need to know what's 25%. So Q1 is 25%. It happens at about 44 seconds. Yeah. So at about 44 seconds, I've squeezed about 25% of the juice out. Then I'll find Q3, which is at about, or is at 75%. So
Over and down.
Yep, 53%.
And she's ballparking or estimating these numbers. Okay.
So I'm saying about in 53 seconds. And then to find the interquartile range, what do?
You subtract those numbers. 53 minus 44 gives you 9 seconds. Right. So that's the sweet spot for squeezing out a lot of juice. So I got a lot of work to do just to get to the first 25%. So I didn't realize it was so hard to squeeze a lemon.
It's real tough. I maybe made this up. Okay. Yeah. And then my last question here is determine the 90th percentile.
So we would do the same thing. We would estimate where 90 is on the vertical, go over to the graph, and then down.
So it takes me about 55 seconds to squeeze out 90% of the juice in the lemon. Okay, so from there, you're going to do about 1 million Khan Academies.
Look at the corgi. Oh, she's so cute. Oh, and the pink shoes.
And the pink shoes, and the pink shoes. Okay, guys, I hope that helped. You got anything to add, Mr. Bobby?
Happy day. See you next.
Bye, guys.